Kratos Defense has successfully completed the first test flight of the Thanatos stealth uncrewed combat air vehicle, which, for any of you who've seen Avengers Endgame, Thanatos should strike fear regardless of what it looks like. But designed for high-risk missions like reconnaissance, electronic warfare, of course, strikes, it's going to reduce the need for human pilots in these dangerous scenarios here. But the drone itself features a tailless, diamond-shaped wing, recessed exhaust, and blended inlets for radar and infrared stealth. Development started back in 2019, public acknowledgement back in late 2023, but they have successfully completed the first test flight of it just recently, which is great. So future enhancements are going to aim to integrate advanced autonomy for fully independent operations. This thing's cool.
Don't want to start out as a bit of a smartass, but I'm sure all of those images we were seeing there was the Valkyrie, not the Thanatos stealth combat drone. Just saying.
Or if you want to be a smartass, you could also say that Avengers Endgame was Thanos, not Thanatos. How are you feeling, Greg?
It's true. It's Thanatos was close enough to Thanos that I'll take it.
Only because these Kratos guys are producing some pretty cool stuff for the future of kind of military training, military combat. So the number one challenge for me on this one is teaching that Thanatos to be the perfect soldier. It's got to be stealthy. It's got to be autonomous. And most importantly, better at following orders than my grandkid following orders after a nap, put it that way. So this is going to be a smart one.
This is new tech. We've got stealthy autonomous drones that can conduct strike missions, intelligence gathering missions. It's intended for those high-risk missions to reduce personnel exposure during combat scenarios. And it's cool that the first flight has happened. So for me, I would argue that the number one area now is getting ready to make these at scale while maintaining the quality, the effectiveness. The design might have some reworks and changes after test flights, but you've got to get ready to manufacture enough of these for the clients, for getting ready to do what you're talking about, Andrew, of, protecting the soldiers, but you've got to manufacture a bunch of them.
Well, I think Kratos are not Lockheed. They're not RTX. They're not the big enterprise. Kratos has got to make sure that they have pre-sold this drone. They've got to. So I think manufacturing scalability is going to come, but I don't think it's there yet, because I think they've got to make sure it's robust. They've got to get the DoD to buy it. So I think whatever you're coming up with there, it's going to be critical, but not yet. I think it's certainly not easy, but that's going to come some way down the line. The real nightmare for me on this one is making sure it's truly autonomous. You're not just programming a drone, you're essentially training a robot to think, decide and act independently in environments which are far more complex than, my grandkid in the kindergarten playground that I was talking about so intelligently a minute ago. The stakes are really high on this one, literally and figuratively. So getting your autonomy wrong, and you've got a really expensive radar invisible frisbee instead of a combat ready UCAV.
You're right. You've got to get the autonomy. It's got to be autonomous, and it's got to do that. But if you don't start thinking about how you're going to actually manufacture these at this point in the process, you're going to be behind. So you've got to start thinking about all of this as you're doing your design. You're still looking downstream, which is why we want to have those systems with the one source of truth, where manufacturing can even start seeing, what could possibly be coming here from this design.
Music to my ears, buddy. Music to my ears. If you are not thinking about manufacturing at scale as part of the whole design process, then you're gonna hit a wall. That's what's going to happen at the end of design when the manufacturing guys get involved. They're going to go, no thanks. It's got to be synchronized. So
the key here is not just snapping your fingers and making it all work.
That's right.
Correct. So what is the key? The key to solving their challenges lies in aligning that autonomy, the stealth, and the operational complexity into a scalable thread and manufacturing environment. So you've got to get your AI-driven autonomy fully integrated with your traditional design and manufacturing processes, make sure you've got your real-time data feedback loops to refine those systems as you go forward, and making sure you've got your traceability for regulatory compliance and safety that the DoD are going to be demanding of them.
I mean, it all starts, the entire process has to start with figuring out what are those autonomy requirements, and what are those requirements in specific mission scenarios for your recon, your strikes, your intelligence gathering, and take those and use system engineering tools to simulate the missions to help further define those requirements so you can build into a requirements traceability matrix, and then use all of that to make those CAD designs for the stealth elements. And I love they came up with the diamond wing. I mean, it looks cool seeing a plane with 2 wings instead of just one, with, you know, putting all that together. So I think that's where this whole thing starts. And then, you know, going from there into visualizing that autonomy, the stealth interactions, using design traceability for the system reviews. What, simulations next?
Yeah, I think it is. I think that's where your digital twin of that Thanatos is going to be built during design. Make sure then that can transfer into simulation. At the same time, I think you've also got to developing a modularized BOM for these autonomy systems, making sure you've got easy plug and play upgrades as you go forward. And then you've got your configuration tracking for stealth and AI integration points. So once you plug that's done, you're then going to plug that into your MRP for your forecasting your demand so that your suppliers are ready to supply. Simulate your production workflows to make sure all of your integrated autonomy, your hardware and your software is all simulated. Make sure that works in a manufacturing environment, speaking to manufacturing at scale, and then develop really detailed digital work instructions for stealth specific assembly processes, and then off you go into your mess mom.
Yeah, and of course we didn't even really touch when I was arguing for let's figure out how we're going to manufacture, and you're still talking about design. But even after that, we've got to look at, you know, using all this operational data to figure out the predictive maintenance and using some of the AI models too. So there's a lot that can happen while you're designing, looking all the way downstream to all these other things that I think is on the right track here.
Yeah. So extending your M-bomb into an S-bomb, etc., P-bomb as well. So yeah, cool.
See you next week.